Hey everybody, welcome to my kitchen. I need you to look in your packet and find this science lab, the Explore Lab Identify Chemical Changes. So we're going to do this lab together. It should be lots of household items that you should have in your house. If not, you can see me demonstrate here. But basically what we're looking at here is you need 4 glass cups or clear Tupperwares. You need a spoon. You need some salt. You need vinegar. It could be white vinegar or apple cider vinegar or any other vinegar. And if you don't have vinegar, you could use lemon juice or lime juice. You would need some filtered water and laundry detergent and the pennies in the supply bag that I gave you. Okay, so you can go ahead and pause the video and assemble all your supplies, and then you can rejoin me in a second. Okay, so let me set this all up here. The computer is propped up on some books. Okay, so what we have here is we have each of our Tupperware or cups. I got the beakers from the science stuff. And in our first one, we've got our laundry detergent and our water. And we measured it out. 1/4 cup of each, and then you stirred it all up. I feel like I'm on a cooking show. Okay, next, number 2, just plain vinegar or lemon juice. 3, we've got our salt water and our salt and our water, making salt water. Huh. And then 4, we've got vinegar and salt. And then I've got my pennies laid out ready to go. Now, fun fact, so pre-1982, so pennies that have a date on them older than 1982 are 95% copper. Like this one here. Usually your dirtier pennies are older, not necessarily read your year, but the ones that are before 1982 are 95% copper. The ones that we see nowadays, they are mostly zinc, and then they've got this really thin copper. Basically, they were dipped in copper to make them look all shiny. So I actually went through and I found and sorted my pennies by their year. And I made sure that I had a mix of old pennies and new pennies in each of my stacks for each of my beakers, because we're looking at chemical reactions, right? Like, how do I identify a chemical change? And I'm really curious because I know that copper is an element on the periodic table. And I want to know how different chemicals, different compounds could impact my copper pennies. So I've got a mix of my pennies, my pre-1982 and my post-1982. And then what we're going to do is I've got my spoon. We're going to put 5 pennies into each beaker. And then I'm going to stir them around. And then I'm going to let them set. I'm going to wipe that off because it's detergent, and just make some predictions while these set. Make some predictions, like we're looking at how our pennies, like they're gonna get cleaner, they're gonna maybe, how do we know that a chemical change has taken place? This one smells like dying Easter eggs because of the vinegar. So I'm gonna stir it for a bit, and I wanna make sure my pennies aren't on top of each other. And then I'm gonna let that one set. And my salt water. So if you think back, do you remember that lab where I had you guys with thermometers? And I brought around all the different compounds, and we did like baking soda and vinegar, right? The really easy one. But the one, do you remember our compounds that we did where we mixed and we saw not only exothermic, giving off tons of heat and a huge temperature change, but also endothermic, where all of a sudden it got colder and it absorbed the heat? So that's all ways that we monitor or we observe a chemical change. And so that's kind of what we're doing with this one too. How can we explore chemical changes going on? So we're going to stir all of these. Make sure they're not on top of each other. Okay, and now I'm just going to make some visual observations. All right, so I'm going to make some visual observations and I'm going to record them in the lab. You're going to record them on your sheet, okay? Obviously, my detergent, if I look on the bottom, I can see my pennies, and I don't really see anything significant. Like, I'm not going, wow, a chemical change. I'm not seeing anything significant. We'll let those continue to soak. Next, I bring up my vinegar, and I just look at them. It really smells like dying Easter eggs. And I look at it from the bottom. Now, I'm seeing just a little bit of bubbling. And I'm kind of seeing some gunky stuff floating off of it. And we remember when we did pH scale and acids and bases, we know that vinegar is more acidic. So it would make sense that there's like some slight bubbling and things. So the bubbles are formed when the copper ions, so if I look specifically at my old penny, that's the one where I'm seeing the bubbles. My newer pennies that are mostly zinc, I'm not seeing as much going on, but my old penny, I'm seeing this bubbling because what's happening is that the copper ions are released from the surface of the pennies in this weak acidic solution. So that's, remember our ionic bonds? So we're seeing this release of copper ions, which is pretty neat. Okay, I'm gonna move on to my salt water. I'm gonna make some visual observations. I am seeing floating chunks of salt that I didn't dissolve very well. But other than that, I'm not really seeing much. Not a whole lot of changes going on in there, but I can kind of see like the murky salt water. And then I come over to my salt and my vinegar, and this one, holy cow. I tossed really grody, dirty pennies into there, and they're like way cleaner. Like I can like see little statue of Abraham Lincoln sitting in the Lincoln Memorial clean. So they're way cleaner. So something happened, obviously, to definitely clean the pennies, because that's pretty crazy. And I'm seeing some bubbling again, which would make sense because of the vinegar in there reacting with the copper ions. So now what I'm going to do is I'm going to spoon them out. I'm going to try and shift this so you can see my paper towels here. So I'm going to spoon them out, and I'm just going to put them on my paper towel if I can find them. There they are. I'm going to put them in front here and just kind of dry them. This is like fishing. 4, 5. Okay. So I'm just going to kind of pat them dry. Okay, my vinegar ones. This is trickier than it looks. Okay, I'm gonna pat those dry. So I'm noticing that my laundry detergent, it did clean. It like broke down the soap element of my laundry detergent, cleaned my pennies because it broke down the oils that all of our hands like to transfer onto money, because money's kind of a germ city, and all those oils. And so the detergent cleaned those up. My my vinegar ones, I'm noticing that it kind of like it cleaned it intermittently. Like there's still a little bit of residue and dirt on them, but they're also cleaner. My saltwater ones, my pennies look the same. I'm not seeing a lot of change there. So I'm going to pat these dry. Let's see here. So, like here's some of my detergent pennies. See? Okay, so they definitely, they're cleaner. They've also kind of got a soap scuzziness on them right now because I didn't rinse them in just plain water. It was the wash cycle only, no rinse. My vinegar pennies, yeah, like I'm noticing one thing that's kind of interesting to me is that my pre-1982 penny, my mostly copper penny, it cleaned up really nicely. It's still a little bit tarnished being older. But my other dirty looking penny is from 1989, which is post 1982, so that means it's mostly zinc. And it's still kind of scuzzy and gross. So that's kind of interesting. I'm sorry if this is blurry. Then my saltwater ones, they look about the same. I'm not noticing a lot differently. My dirty penny, yeah, it's still kind of gross. And my salt and vinegar ones, I'm noticing something kind of peculiar. And I'm hoping that you'll do this lab so you can notice this too. So my salt and vinegar pennies, I like salt and vinegar potato chips. All right, my salt and vinegar pennies, my post 1982 one, this one's from 1997. It cleaned up, sorta, but it's also kind of gunky still. And if I set that to the side and I look at my other ones, now this one, 2006, so that one doesn't apply. My old ones, my pre-1982 pennies, they have this chalky film on them, almost like they're tarnishing. Because they are tarnishing. There's this almost white turquoisey, you know how we talked about like the Statue of Liberty being green and it originally wasn't, that's just the aging of it. That's almost what is taking place here. It's like a turquoise compound, and what this is that the free copper ions that the vinegar and salt released, copper still wants to hang out with copper, right? And so those free copper ions, they're still on the penny surface and now they're tarnishing, and yeah, it's just a visible chemical change that we were able to see. So let me flip back over to our lab sheet here. So I can record all of my observations. I would have been doing that as I went. And so I kind of recorded them verbally with you. And then we've got just why do you think each reaction happened? And then in what cup do you think a chemical change occurred? Okay, so in our next lesson, we're really going to be zeroing in on how do we observe chemical changes. A chemical change, in its like dictionary definition, it is identified by the formation of a gas. Didn't really see that unless you count the bubbles, right? The bubbles could be evidence of a gas. The formation of a precipitate. Okay, so a precipitate, we could say, well, maybe the tarnish on some of these is that. A change in color, these kind of got chalkier. Or a change in temperature. Now, none of these demonstrated a temperature change, but we've observed that before. So a chemical change is identified by the formation of a gas, the formation of a precipitate, a change in color, or a change in temperature. And we're going to be looking at these chemical changes in the next lesson. But this is just kind of your kickstart lab to really just kind of get looking for these chemical changes yourself. And I'm really excited to see your results. and to see how your pennies clean up and what you observe and with the different ages of your pennies. I'm also really fascinated in like how different detergents clean. Like I didn't have enough pennies to use my made at home detergent that I use. I use the store-bought Tide. So I'm really interested, like how do the different detergents clean stuff? What's the difference between if I used Himalayan pink salt and or just my plain old table salt? What's the difference if I use non-iodized salt versus iodized? There's so many different variables that we could maneuver and compare and contrast with our results. So I'm so excited to see how your labs go. Thank you so much, and let me know if you have any questions.